I know that Chairman Turner's letter to House members and his subsequent post on social media about a national security threat has prompted a lot of questions. While I am limited by how much I can share about the specific nature of the threat, I can confirm that it is related to an anti-satellite capability that Russia is developing. I want to be clear about a couple of things right off the bat. First, this is not an active capability that's been deployed. And though Russia's pursuit of this particular capability is troubling, there is no immediate threat to anyone's safety. We are not talking about a weapon that can be used to attack human beings or cause physical destruction here on Earth. That said, we've been closely monitoring this Russian activity, and we will continue to take it very seriously.
The new space race has sparked growing concerns about heightened space defense measures in recent months. The statement from the White House spokesperson John Kirby came a day after a senior House Republican issued an ambiguous warning about a significant national security threat. Kevin Lausten, president of Morpheus Space, joins me to discuss the modern-day space race, space defense, space mobility, and Morpheus Space's latest achievement, the GO-2, which bears a striking resemblance to a Star Trek Borg Cube. Join us as we get rebelliously curious. Kevin, thank you so much for joining me on Rebelliously Curious today. I'm really looking forward to having a conversation with you on space defense, the modern day space race, along with what is space mobility and why is it important. Before we get into those discussions, can you tell me what is Morpheus Space?
Sure. Morpheus Space is a space company that was built to address the needs for space mobility as a whole. We have a mix of hardware and software products that are intended to address the increasingly complex dynamics that are occurring in the space environment today. So space is becoming more contested, more congested, more regulated. And with these key themes going on in the space ecosystem, this really drives a need for space mobility products. People need to be able to confidently move their spacecraft to address issues like space debris and conjunctions with other spacecraft. They need to be able to maneuver in situations where adversaries are approaching their spacecraft. And then increasingly, as space becomes more congested, the governments around the world are applying a greater level of regulation to operations in space. And so with that regulation, there's an increased need for spacecraft operators to be able to deorbit elegantly. And with all of these factors at play, the need for space mobility just continues to increase. So Morpheus Space was envisioned and built to address the needs of the space mobility world and provide the products and services that allow spacecraft operators to operate with confidence.
That's awesome. Can you tell me what space mobility is? Because a lot of people might not understand that terminology. Can you give me a breakdown of what that means?
Sure. In its simplest form, Chrissy, the term space mobility suggests the ability to maneuver in space. So the way that spacecraft have traditionally operated is they're launched by a rocket and then placed into an orbit. And then 10 or 20 years ago, gravity sort of did its trick and kept spacecraft in the target orbit that they were deposited in. And spacecraft would maintain that orbit for the duration of their lifetime. And then eventually gravity would pull spacecraft back down to Earth, and spacecraft would burn up on reentry. And that would happen, between 5 and 15 years after a spacecraft entered its orbit. Now, as space becomes far more congested, you need to be able to move in space and not just allow gravity to do its trick. You need to be able to navigate around other objects in space. And those could be objects that are orbiting on their normal path, or those could be objects that are moving towards you for one reason or another. So not only do you need to be able to have the propulsion on spacecraft to perform those maneuvers, you need to be able to plan and operate your mission knowing that maneuverability will be important. So that's where the software piece of our company comes into play, is the mission analysis and design. We take into consideration a wide range of input variables, things like space debris, things like target orbits that our operator partners want to participate in, and create the interface that allows these operators to plan their missions and execute on their missions, knowing that they're going to need to maneuver once they get to space.
For sure. And there's a product called the GO-2, I believe, if
Yeah.
I'm saying this right, or the
Right.
GO-2, and it's the size of a Star Trek Borg Cube. Can you give me an idea of what that is and what you're using it for in Morpheus Space?
Yeah, quite simply, this is a propulsion unit that affixes to the side of a spacecraft that allows spacecraft operators to create force, right? So to move a satellite in space, you need to be able to create thrust, create force, right? To create the push that moves the spacecraft from point A to point B. In the absence of a propulsion unit that sits on a spacecraft, gravity will just keep a spacecraft in its standing orbital path. So think it's just making a rotation around the Earth at a very predictable pattern. And then if you need to make a change, that's when propulsion comes in to raise the orbit or adjust the inclination angle. You need a propulsion unit on board to be able to perform that type of maneuver.
So how big is this propulsion unit? Like I
Yeah,
would like, because that's the question, like a Star Trek Borg cube is, I would imagine, is, from what I've seen, is not that big. But how big is it in practicality? And has this changed over time? Because we look at things like, for example, even a computer, how they were so massive and now they're becoming so much smaller. Is this the same type of concept, that it's becoming very, very tiny units that have a lot of thrust behind them?
Yeah, Chrissy, that's a great analogy with the trajectory that computers have been on. We used to have these massive mainframes, and now we have, the power that those mainframes had back in the 60s. We have that in our pocket. The same dynamic is occurring with spacecraft and space technology. We used to have billion-dollar spacecraft that took decades to produce, that were the size of trucks. And that was the standard approach. And not only did the cameras and the power units, but the propulsion units, they were all just big because they needed to be, right? That there weren't advances in technology that allowed them to be miniaturized. But as the technology has developed over time, things have been miniaturized, and now we can perform similar operations with a much smaller form factor. And so this is the case with spacecraft as a whole, and propulsion units. They used to be the size of, a dishwasher. And there are still propulsion units that are that big, but we're now seeing spacecraft that are the size of a bread box. And we're able to compress our propulsion units down to a cube that's 10 centimeters on the side. Yeah, we were just at an industry event just earlier this week, where we were able to walk around the show floor and have 3D printed prototypes of our propulsion unit in our backpack. And we could just show it to our partners and our customers and hold it in our hand. It's that small. Though the way that the industry has been going is more and more standardized and more modular capabilities. So you've got these relatively small propulsion units, but you can use one on a very small spacecraft. If you need a little bit more, you can use two. And if you need a lot more, you can use 16. And they're all the same form factor. And so they can be clustered to support a wider range of missions for larger spacecraft.
So are these attached to a spacecraft when it's lifting off and going into orbit, or are these separately launched?
Yeah, so these are attached to spacecraft before they're launched in most cases. There are some really exciting innovations happening in the space ecosystem, where there's the idea of adding propulsion to spacecraft after it's already been on orbit to extend the lifespan of the spacecraft. And so we're involved in those conversations with some of our partners, which is very exciting. The whole notion would be you launch your spacecraft with only the propulsion you need for the first phase of the mission. And then there's an on-orbit servicing system. Think of it like a gas station or a mechanic shop in space that can do work or add fuel after you've been on orbit for years already. And so we're working with those partners with the idea that those partners would take dozens or hundreds of our GO-2 propulsion units to space, and then add them to spacecraft as needed when they decide that they want to extend their mission duration or their mission changes, perhaps, or they need to deorbit ahead of plan and they need to add propulsion to their spacecraft to be able to deorbit in an elegant fashion based on FCC requirements. The traditional path was take a dishwasher-sized propulsion unit and attach it and hope that in 10 or 15 years, it's still doing what you want it to do. Now you can add in a small propulsion unit that can fit in your backpack, potentially halfway through the mission duration and adjust the plans of the mission for that spacecraft.
How does this change the game? How does it change the space race game in general? Because I imagine it would. Things are more accessible, and not even just looking at government agencies doing any type of exploration. Now we can get individual and private companies doing this. So what are you seeing right now in the field?
Yeah, so there have been a lot of changes in the field over the last 10 years. SpaceX has really been leading the charge in terms of changing the way that the industry as a whole can think about space. So the cost for payload to orbit was about 100x a decade ago than what it is now. So that is wild, right? And that's largely driven by the progress that SpaceX has been able to achieve. But there are many other launch companies coming on board that are going to be taking advantage of the opportunities that are now available in terms of launch cadence and spaceport availability. And what that means for the companies that want to operate in space is you can get much more creative. Because if it previously cost you $100 million to get a certain amount of payload to orbit, and now it costs $1 million, you can be far more creative with your business plans. You can be far more aggressive with the strategies that you implement to generate a business that's based on the space economy. So what we're seeing is companies that are building constellations of spacecraft, constellations of satellites that are intended to perform a wide range of activities. So this could range from Earth observation, taking pictures from space of the surface of the Earth, using different technologies. This could include communications. This could also include producing pharmaceuticals in zero gravity environments and then bringing those pharmaceuticals back down to Earth. There are certain chemical processes that can only be performed in zero gravity environments. And there are pharmaceutical companies that now want to take advantage of this opportunity that's been created through the dramatic decrease in the cost to get to space. And now they can start to manufacture things to make life on Earth that much more enjoyable and safe and secure. So there's all these changes that are happening. And what this means in terms of space mobility is as you add each new spacecraft to low Earth orbit, you need to be more and more mindful of your neighbors and being a good neighbor and being able to navigate effectively and safely in that environment. If you're the only car driving on the road, then you can just drive straight and not really pay attention to any other drivers, right? But if there's 100 drivers on the road or 1,000 drivers on the road, you need blinkers. You need a steering wheel. You need to be able to speed up and slow down. And that's the kind of service that we provide. We see that the space highway is getting more and more congested. And so we're providing the capabilities that allow people to navigate effectively in that new environment.
Traffic control.
You got it.
Pretty much. So what
Yeah.
are the pros and cons then? Because should people be worried about this as we're getting more private companies involved? Because you see that depending on what their agenda is and what they're looking to accomplish and who's also funding it. Are there things that we should be worried about? And how do we stay safe when we're looking at this type of expansion within space?
Yeah, it's a good question. I think about the environment that we're operating in first from a glass half full perspective. I think there are tremendous opportunities that are created for individuals and societies based on the dynamics we were just talking about and the increased ability to operate within space. I firmly believe that our ability to operate successfully in space makes life better here on Earth. Though there are some risks, there are some challenges, and there are some signals that there are adversary nations that are embarking on activities which make space the next war domain. There are nations that are space-faring nations that are launching capabilities and spacecraft that are demonstrating the ability to maneuver and approach spacecraft. And this could be done for a wide range of purposes. You may want to get really close to a spacecraft to take observations, to understand what that spacecraft is there for. So, an adversary nation may approach a spacecraft and try to determine, is this a Earth observation spacecraft? Is this a communication spacecraft? Is this something else? And some of those observations can be made from the ground, but if you can approach a spacecraft within, a kilometer or even a couple hundred meters of that spacecraft, you can take an image, you can take observations, and infer with far more detail what that spacecraft is actually intended to do. Now, that's more of a passive observation. As you go further down that chain, there are scenarios where there can be an actual interaction between two spacecrafts. So we're seeing technology developed for a wide range of reasons that can reach out and touch a spacecraft, 1 to 2, one A to B, and think of a robotic arm.
Right.
If you have a spacecraft with a robotic arm that can maneuver, if you have, if Western nations have a highly valuable space asset and an adversary nation approaches that asset with a robotic arm, that can do some substantial damage. Physical damage, the cybersecurity risks are possible there as well. Introducing malicious signals and nefarious software into one of our spacecraft, that starts to become a reality or a possibility. So that is scary, and we need to be mindful of that. We need to be aware of that. We need to be watching out for what everybody who is operating in the space ecosystem is doing and try to infer what they may want to do in the future.
And we need to have tactical responses in space. Currently, do you know what those might look like or what you've seen has been deployed from not even just North America, from other different countries?
Yeah, so active deterrence is a compelling strategy. So if your adversary has a certain set of capabilities, you need to demonstrate that you have comparable, if not superior, capabilities to prevent them from, pushing the envelope. So as we see adversary nations demonstrate capabilities, as Western nations, we are also demonstrating capabilities to create that active deterrence. I have to draw this back to mobility. If you observe that an adversary is approaching your spacecraft, being able to quickly maneuver and do something to evade that interaction is an important capability for Western nations to have, especially with those most valued assets.
For sure. And I remember reading a few stories a couple years ago about China having a satellite killer where they would attach, you were saying, an arm onto, say, one of our North American satellites and overtake it and become one of theirs, almost like some kind of form of transformer. Where are we right now with that? From what you're seeing, how are we defending ourselves with that? And what type of technology are we building even outside of space mobility and adjacent towards it? or
Yeah,
adjacent to
so
it?
yeah, there's this starts with awareness, and there's a big push these days for space situational awareness, and there are a wide range of strategies that are being developed both on the government side and more on the commercial side. There was an interesting company that I got a chance to meet with earlier this week called Leo Labs that has a ground-based radar system where they are taking inventory of all of the operators that are in space by sending signals from the ground up and then measuring the return back at the ground to infer really who's up there, what are they doing, where are they going. And by taking those measurements on a frequent basis, they're able to create a dynamic map of space. And so this creates the awareness that is necessary to have a database of all the operators in space. And then as you start to build that awareness and you start to see what other assets are up there and where they're going and what they're doing, then you can start to build strategies to address different scenarios that could be explored by adversaries. For each capability that our adversaries demonstrate, Western allies are going to demonstrate similar, if not superior, capabilities to create that active deterrence that I was talking about beforehand. This does create a bit of a Cold War space race dynamic. As one side builds up a capability, the next side builds up even more, and then that grows over time. So the capabilities that you were talking about with the Chinese arm that folks have read about in the news, that's becoming a common capability across big operators in space. There's also non-kinetic laser-based technology that has been demonstrated for anti-satellite missions. We've seen that out of a range of adversary nations. When it comes down to it, there's a range of capabilities that need to be available to Western allied nations to be safe and to operate successfully in space. Space mobility and being able to maneuver with confidence and without regret is a really important cornerstone of that security aspect.
Yeah, and you mentioned the Cold War aspect of this. Do you feel then potentially in the future, instead of, ground-based war games, that we're going to be moving this to space more and more? That this will be a place where of battle, per se, because of all the communications, all the technology, and the ability to target communities and countries very easily from space.
Yeah, I sure hope not. There's irreparable damage that can be done if the war goes to space. There's a concept that has been understood and explored extensively that talks about how some type of explosion in space, if it were to get to that, could have damage that affects us centuries into the future. If you think about a spacecraft that gets destroyed and a single space object turns into 100 or 1,000 or 10,000 space objects because it's been destroyed, that becomes space debris that goes in a wide range of directions and may create and trigger other other similar types of destructive activities to spacecraft. And then one spacecraft becomes 5 that have been damaged and have broken into multiple pieces, and then all of a sudden there's belts of debris that dominate certain orbits within space. And the extreme would be certain orbits are off limits from operation because there's such tremendous levels of debris. So I sure hope that every operator in space is thinking about that. I think they are, but it doesn't mean that space won't become the next war domain. It's a scary thing to think about, and I'm hopeful that diplomacy and active deterrence keeps those sorts of scenarios at bay.
Right. And there are treaties put forward to protect us. There's hope that foreign adversaries don't go against these treaties. We've seen potentially that Russia has gone against these. We see that there are uses for nuclear weapons within space. Do you think that potentially now, from what you're seeing in the landscape from a private sector, that the ability of using nuclear warfare in space is going to be something that is looked upon? Because we have, had countries like Russia and other countries speak of this and potentially use it. Nothing that would potentially affect us currently now, but it is a concern.
Yeah, I would see that as more saber rattling than anything else. Uh, Use of nuclear weapons in space, it doesn't carry a ton of like logic, if I'm honest. Nuclear technology has a tremendous value in terms of using it as a propulsion system. Though using it as a weapon system seems highly unlikely. So if you think about nuclear technology, it has the ability to create almost infinite power over very long durations. And so as we think about moving beyond Earth's orbit and exploring the deep corners of the solar system and beyond, nuclear technology really feels like the path to create the power necessary to propel spacecraft and space transport vehicles to the far reaches of the galaxy. So I think nuclear technology very much has a place in the space ecosystem. I think it's fairly unlikely that it will have an impact in terms of the defense side of things. It'll has far more potential in terms of reaching the far corners of the galaxy.
Agree. And what do you think the average person does not know and should know about space defense and even space mobility?
Space is far more congested than people realize. It's a busy world up there. There are tens of thousands of spacecraft on orbit today, and there are plans for that to increase by a factor of 2 or 3. I'm sorry, by an order of magnitude of 2 or 3. So space is becoming very busy. It's easy to look up at the sky and think that it's empty, and it's getting increasingly busy. The economics of getting to space are allowing for this to happen, and those economics are becoming more and more attractive, and the technology advancements are becoming better and better. So there's a wide range of factors which are driving this increase in activity in space. And with each new participant in space, that increases the need for mobility for everybody who's operating in space. So space is big, space is growing. But with that, there's a need to make sure that everybody's operating in a way that keeps everybody safe. And the cornerstone of that is awareness of where everyone is and the ability to navigate effectively.
And seeing that you've worked in this space for a while now, there has to be some best practices that you would say to different governments working around the world. What would those be and what would they be? How would they be implemented in your perspective? Because we know from government, they're not always the quickest. Sometimes they're not as adapting as fast. And the private sector, especially in Canada, within our government, does move quicker than government officials and government bodies. So what best practices would you say should be implemented in this and done now?
Yeah, I think it's really important for multinational policy and treaties to be implemented to really establish some norms around what should and shouldn't be done in space. I think this is very aspirational because you've got different nations with different objectives and different social and cultural norms. But it's something we should invest time in. We owe it to our future generations to try to establish these norms and these policies and these treaties to ensure that people operate in space with the best intentions of the people on Earth. There's a risk that damage is done that's irreparable. And if we don't establish those policies and those norms and those standards to ensure that space is a safe place to operate, we're going to be apologizing to our grandchildren. And I don't want to be in that position. I think none of us want to be in that position. And we owe it to them to put energy into working from a diplomatic standpoint with every operator in space to find common ground and develop a set of norms that works for everybody.
I agree with you. I 100% agree with you. Let's leave them something that they can work with and put together best practices and capabilities now before it's too late. Kevin, thank you so much for joining me on Rebelliously Curious today. And I look forward to speaking to you hopefully again soon.
Great. Thanks for your time, Chrissy.
Thanks.